Imagine this. Voyager 1, the most distant human-made object, speeding through space at 38,000 miles per hour, 14 billion miles away from us. It's been traveling for over 4 decades. Suddenly, it runs into a serious problem. The thrusters, critical for keeping Voyager aligned to communicate with Earth, are starting to fail. If it loses contact, we lose one of the greatest space missions ever. NASA engineers are faced with a mind-bending challenge. How do you fix a spacecraft that's so far away it takes over 21 hours for a single command to even reach it? But first, let's back up and understand the context. Why are these thrusters so important to the mission's success? Well, Voyager 1 has to remain in perfect alignment with Earth to send data back to us. Its main antenna must point directly at us to ensure a clear and uninterrupted communication link. But in the cold vacuum of space, tiny forces like solar wind and gravitational tugs from planets can slowly knock Voyager off course, even if just by a fraction. That's where the thrusters come in. They are crucial for making those tiny but essential adjustments. Every so often, Voyager fires them to make small adjustments and stay on track, ensuring it remains aligned with Earth. The problem? After decades of use, Voyager's primary thrusters were degrading. They were not as reliable as they once were. They weren't firing with the same precision they once had, which posed a significant risk to the mission. If they stopped working entirely, Voyager would drift, its antenna would misalign, and we would lose contact. The spacecraft would go silent forever, ending one of humanity's most remarkable journeys into the cosmos. Thankfully, NASA engineers found a solution by switching to backup thrusters, ensuring Voyager 1 can continue its mission. This quick thinking has allowed Voyager 1 to keep sending valuable data back to Earth, even as it travels further into the unknown. Voyager 1's journey continues thanks to the ingenuity and dedication of the team at NASA. Fixing this wasn't going to be easy. The challenge was monumental, and the stakes were incredibly high. For one, Voyager is ancient by today's standards. It was launched in 1977, and its technology is a relic of that era. Its technology is like the equivalent of a 1970s computer running on 8-track tapes. Imagine trying to fix a computer that old from billions of miles away. And remember, Voyager 1 is 14 billion miles away. That's farther than any human-made object has ever traveled. NASA couldn't just send a repair crew or beam over a software patch. The distance made any direct intervention impossible. Any command sent from Earth takes over 21 hours to get there, and another 21 hours to know if it even worked. This delay meant that real-time troubleshooting was out of the question. The team needed a solution, and fast. The pressure was on to come up with a creative fix that could be implemented remotely. With the main thrusters failing, Voyager's days were numbered. The spacecraft was at risk of losing its ability to communicate with Earth. But here's where things get interesting. The engineers at NASA remembered something crucial. Back in 1980, just after Voyager had completed its grand tour of the outer planets, it used a different set of thrusters called the Trajectory Correction Maneuver, or TCM thrusters. These thrusters were designed for precise adjustments during its journey. These hadn't been used for 37 years. The team had to figure out if these dormant thrusters could be brought back to life and take over the job of the failing main thrusters. They ran simulations and tests, hoping that the TCM thrusters would still function after decades of inactivity. It was a long shot, but it was their best hope, and against all odds, it worked. The TCM thrusters fired up, and Voyager 1 continued its journey, sending valuable data back to Earth. This incredible feat of engineering ensured that Voyager's mission could continue, even from 14 billion miles away. NASA's idea was bold. Could they fire up these dormant TCM thrusters after nearly 4 decades of inactivity? There was no guarantee this would work. These thrusters hadn't been touched since Voyager 1 passed by Saturn in 1980. But if they could somehow reactivate them, it could keep Voyager on course for a few more years. Sending the command to fire those thrusters was a risky gamble. If it didn't work, Voyager's ability to communicate with Earth could be lost for good. And remember, it would take 21 hours to get a response. The waiting game 21-hour delay. NASA sent the command. Then, the agonizing wait began. Imagine waiting nearly an entire day just to see if the thrusters would fire. 21 hours passed. Then, another 21 hours for the signal to return to Earth. Finally, after 42 hours, the data came in. The thrusters worked. Success! Voyager is back on course. Against all odds, the thrusters fired successfully after 37 years of dormancy. Voyager 1 was back on course and NASA engineers celebrated. This move gave Voyager 1 several more years of life, allowing it to keep sending data from the farthest reaches of our solar system. Thanks to this bold decision, Voyager 1 continues to explore the unknown, sending data from billions of miles away, pushing the limits of human exploration. The future. What's next for Voyager 1? But the story doesn't end here. Voyager 1, launched in 1977, has been traveling through space for over 4 decades. Voyager 1 is still out there, moving deeper into interstellar space, far beyond our solar system. It has crossed the heliopause, the boundary where the solar wind from our sun meets the interstellar medium. Its power is slowly depleting, and at some point, it will fall silent. The spacecraft relies on its radioisotope thermoelectric generators, which are gradually losing their ability to produce power. But for now, it continues to beam back data, giving us a glimpse into the unknown. This data includes information about cosmic rays, magnetic fields, and the density of interstellar space. NASA's quick thinking and ingenuity have bought us precious time with one of the greatest space missions ever launched. Engineers have been able to manage the spacecraft's power consumption, turning off non-essential systems to extend its operational life. So, what's next for Voyager 1? As it continues its journey, it will keep sending back data until its power runs out. While its time is limited, NASA is monitoring every signal, every piece of data. Each transmission is a treasure trove of information, helping scientists understand more about the universe beyond our solar system. As it ventures farther into the unexplored, it reminds us of the power of human innovation and our endless curiosity to reach for the stars. Voyager 1's mission may eventually end, but its legacy will continue to inspire future generations of explorers and scientists. Voyager 1's journey isn't just about exploring space. It's a testament to human persistence and ingenuity. A spacecraft built in the 1970s, repaired from billions of miles away, still teaching us about the universe. Who knows what mysteries it will uncover next?